Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
A study of hydroacoustic, acoustic and seismic waves from underwater explosions off the French coast could help guide the disposal of unexploded World War II ordnance (UXO) in those waters, according to a new study published in the Bulletin of the Seismological Society of America. The French Navy Mine Warfare Office routinely destroys this ordnance with countermining, detonating a charge placed next to the UXO, to make the sea safe for ships and divers. The countermining charges are located on the seafloor or in a barrel floating in the water column. Even small explosions can trigger effects such as underwater landslides or waves that could potentially damage shoreline and underwater infrastructure such as pipelines and cables, making it important to understand how these detonations behave and to limit their damage. Michael Bonin of the University of Nantes and colleagues had a unique opportunity to observe the effects of countermining explosions in December 2018. The researchers analyzed the seismic records of 8 underwater explosions in the Bay of Hyères off the southeastern coast of France in the Mediterranean Sea. The data were recorded on hydrophones, a shock gauge and a dense array of seismic stations located onshore no further than 15 kilometers from the explosions. The explosions themselves were equivalent to 80 to 680 kilograms of TNT. The most energetic signals recorded by the array were high-amplitude, high-frequency hydroacoustic or H signals. The researchers detected these signals at stations on rocky sites near the shoreline, suggesting they were likely conditioned by the shape of the bay and the sedimentary cover of the seabed. Bonin said the research team was surprised to be able to observe the H signals at all. As seismologists rather focused on the study of the crust and the lithosphere, we were first interested in low-frequency signals, of less than 50 Hz, he explained. But by configuring the stations to record at high sampling rates, of 200 Hz and up, the team was able to observe the signals at some stations. These are observations that we would like to investigate further, he added. In particular, we would like to know if H waves can be observed further inland. The findings may also shed light on whether countermining explosions are less destructive and intrusive when placed on the seabed or in the water column. Placing the explosion in the water column rather than the seabed limits the release of seismic energy, so some experts prefer it to limit potential onshore damage. However, the researchers' observations of the seismic signal of the nearby St. Anne bell tower on Porquerolles Island found that even the largest explosion among the detonations did not release enough energy to damage the masonry structure. Explosions in the water column, on the other hand, can cause a noise nuisance that is damaging to sea animals. Bonin and colleagues found that while explosions in the water column do limit the release of seismic energy between 1 and 10 Hz, an explosion in the water column generates dramatically more energetic H signals than the same TNT equivalent explosion on the seabed. We think that limiting the seismic energy release is probably not necessary in view of the impact that an explosion in the water column can have on aquatic fauna, Bonin said. Moreover, we are not entirely sure that the discomfort that may be perceived on shore by the population is due to the seismic waves, he added. It is possible that it is caused by H waves and perhaps by acoustic waves. These two types of waves see their energy maximized when shooting in the water column. The study is part of a BSSA special section in on seismo-acoustics and seismo-acoustic data fusion. Make a difference. Sponsored opportunity story source. Materials provided by Seismological Society of America. Note: content may be edited for style and length. Journal reference: Michael Bonin, E. Diego Mercerat, Éric Boycoler, Nathalie Favretto-Cristini, Anne Deschamps, David Amboise, Thierry Garland. Short-range recordings of shallow underwater explosions with short-period and broadband seismometers in the Bay of Hyères, France. Bulletin of the Seismological Society of America, 2022, doi. 10. 1785, 0120220141. Cite this page. Seismological Society of America. Hydroacoustic signals help study impacts of underwater explosions off French coast. Science Daily, the 28th of November 2022. ift.tt/pdwrfch. Seismological Society of America. 2022, November 28. Hydroacoustic signals help study impacts of underwater explosions off French coast. Science Daily. Retrieved November 28, 2022 from ift.tt/pdwrfch. Seismological Society of America. Hydroacoustic signals help study impacts of underwater explosions off French coast. Science Daily. https://ift.tt/pdwrfch. Accessed November 28, 2022. Thanks for watching. Please subscribe my channel for more videos.